the sum from n equals 1 to infinity n to the 8th e to the negative n to the 9th. Is this a P series? No, because of the E, right? All right. So what do I do? Rewrite it as a function. And it might help if you think about this, because I have a negative power here. I can move it to the denominator and make it positive. Then what? What do I have to check? Okay, so let's start with the positive. Is that positive? Yeah, the numerator is positive, the denominator will be positive. So this is positive on my interval 1 to infinity that I'm considering. What about continuous? Yeah? Is the denominator ever 0? E to a power is never 0, okay? So this is going to be positive and continuous on this interval 1 to infinity. The positive and continuous part is usually immediate. You just have to double check. The part that's more work is showing that it's decreasing, right? So let's take the derivative of this. What am I going to get for the derivative? What? So you have two options. You can either do the product rule, or I've already written it as a division. You can do the quotient rule. Let's go ahead with the quotient rule, right? What's the derivative going to be? E x to the 9th times what? 8x to the 7th, minus 9x to the 8th, e to the x to the 9th, and then times the top, x to the 8th, ex to the 9th squared. Okay? That looks awful ugly, right? But no worries, things are going to simplify kind of nice. If you notice, both terms in the numerator have an ex to the 9th in them, right? So you can factor it out. X to the what power? 16th, Well, now I can cancel. I have an ex to the 9th in the numerator and an ex to the 9th in the denominator. So we can cancel 1. Can I factor out something else out of the numerator? X to what power? 7th, okay? X to the 7th, we got 8 minus 9, x to the what? 9th, And again, this is the derivative, so I'm worried with when is this negative? Is the denominator ever negative? No, because it's e to a power. Is x to the 7th negative? No. So the only part that could be negative is this part that's inside of this parentheses right here. That's the only part that could be negative. So I want to know, when is that part that I circled, when is that negative? When is this less than 0? So if I divide by 9, I get 8 over 9. And then I take the 9th root, But we're focusing in on this interval 1 to infinity. Yeah. So you don't have to worry about x being negative. Yep. Well, the ninth root of 8 over 9, that's a number smaller than 1, right? Because 8 over 9 is less than 1. And then you take the ninth root of a number less than 1, you get less than 1. So this tells me that x is decreasing on the interval 1 to infinity as well. Okay? So a lot of times it's a lot of work to actually show that your function is actually decreasing. Remember, if your function's not decreasing, you can't use the integral test. So you have to check this. Yeah.
I'm still a little confused on.
Mm-hmm.
So I mean, if x is less than 1,
Mm-hmm.
right here.
But we're not considering x less than 1 because if you look up, my bounds on this sum are 1 to infinity.
So it's just like the last one.
So I'm only looking, so this means that the interval that I want to consider is 1 to infinity. Okay, so for the first part, positive and continuous, it needs to be on that whole interval that it's positive and continuous, okay? For the decreasing part, it's okay if it's not decreasing on the whole interval. So for like the last example, square root of 3 was when it started decreasing. It wasn't decreasing on the whole interval, but that's okay. It just needs to be decreasing after a point.
Oh, okay. So as long as it's after a certain point.
Yeah, it's okay if it's not decreasing in the beginning, but then after that, it needs to be decreasing on. But here, it is decreasing the whole time. From on 1 to infinity, I'm decreasing the whole time. Okay. Okay, great. We showed it was positive, continuous, decreasing. What do you do from here? Integral. We're going to compute an integral, right? So we're looking at the integral from 1 to infinity, x to the 8th, e to the negative x to the 9th, dx. Do what? Put in the limit. Yep, you're right. Put in a limit. Limit as t goes to infinity, 1 to t, and then x to the 8th, e to the negative x to the 9th, dx.
You do integration by parts.
You could? Yeah, what would your u be? X to the 8th and the dv. You can do u sub, yeah. Yeah. So you have two options. You could do integration by parts or you could do u sub. But because you have an x to the 8th power, that means you're going to have to do integration by parts 8 times. Yeah, which we don't want to do, right? We'll all agree to that. I don't know. The easier thing to do is the substitution that's there. So sometimes you do have options. Just one of them is easier than the other, okay? And generally, substitution is always easier. So what's my u going to be? We'll go ahead and, let's go ahead and incorporate the negative into it as well. So what's du going to be?
Negative 9x to the 8th.
Uh-huh. All right, so let's do our substitution here. We've got the limit as t goes to infinity, e to the u, and du, and I'm going to have a negative 1 over 9 here. And what are my new numbers for my bounds? Negative 1, negative t to the 9th. Okay. What's the integral of e to the u? E to the u. And this is why I went ahead and incorporated the negative into the substitution, because otherwise you're gonna have to do, make sure you remember there's a minus there, okay? So negative 1/9 e to the u.
Okay, how do we get negative t to the
We take, to get our new bounds, what we do is we take them and plug them into our substitution equation here. So I take 1 and put it in place of x. I'll get negative 1 to the 9th, or just negative 1. Take t and plug it in, negative t to the 9th, okay? All right, so let's see, we plug in our bounds, right? Negative 1/9 e to the negative t minus a negative, so plus 1/9 e to the negative first. And now the question becomes, what is that limit?
First part is 0.
How do you know it's 0?
You have a negative exponent.
Uh-huh, so how do you deal with negative exponents when you're doing limits? You rewrite them.
Rewrite it, so it would be 1 over e to the t to the 9th.
So I move it to the denominator. You can go ahead and move that one if you want to the denominator as well, it doesn't matter. And now, once I have positive exponents, I can actually calculate a limit. And here, I get negative 1 over a really large number. So that's why I'm getting 0 for this limit. Okay, I computed this integral. What do I do from here?
That's a number.
It's a number?
1 over 90, is that gonna be your?
Well, when we do the integral test, that doesn't tell us the sum of the series, but yeah, you got a value for this, right? So the improper integral converged, which means the series converges as well, okay?
We don't do anything with that number.
No, you don't do anything with that number. All you care about is if that's a number or not. If you get, yeah.
So that doesn't mean that the series itself converges to 1 over 9.
No, because remember, the integral is just like an approximation for the series. It's not actually telling you the exact value. Yeah. Okay, so the series n to the 8th, e to the negative n to the 9th converges. Again, you would say by the integral test, because that's what you're using.